Hello YouTube, this is Dennis. Today I'm going to show you how I built my simple power wall using different parts that I bought from AliExpress. Let me show you how I build it. In this build I use an old plastic box which was a first aid kit box. The reason why I use this box is basically for three reasons. It was big enough to accommodate all my components that I needed for this simple power wall. Secondly, it is plastic, so you have insulation, almost 100% insulation of your different electrical components from one another. And thirdly, it was partitioned, so you could place your different parts of this power wall in those partitions. So the first component of this build are the lithium iron phosphate batteries. These are 43180 cells that are arranged in a 4S2P configuration. The 20 ampere hour batteries that are giving me a total capacity of 40 ampere hours. There are 8 pieces. The second part of this power wall is a transformer. This is a step down transformer that I pulled from an old UPS. It is a step down transformer which is whose input is around 220 240 and giving me an output of 23 volts. On that small circuit we have a bridge rectifier for converting that AC into DC, and a filter capacitor for smoothing my DC towards a straight line. You know, DC is supposed to be a straight line. So the third component of this build is this DC to DC buck converter. As you see there, it has an input of around 23 point some, 0.3, 0.8, 0.9, and I need only 14.6 to charge my batteries. As I said, I have a 4S2P. Those are lithium iron phosphates, and you know, for those cells to be fully charged, each cell must be around 3.6. So for a pack which is a 4S2P, I need a total of 14.6 for those batteries to be charged. And you see there, the batteries are about to be full. So the DC to DC buck converter is the one which is helping me to regulate the 23 to a 14.6, which is the required voltage for charging my batteries. So the fourth part of this build is the BMS. This is a BMS from Chargery. It is called BMS 8 from Chargery. It can support both LiPo and lithium iron phosphate batteries. As you know, for these batteries you need to balance them for these cells to work for a long time and to avoid damage. So me, out of this one can support up to 8 cells in series, but me, I'm only using only the 4 because my configuration is a 4. So you can see there, it can indicate the difference between the lowest and the highest cell. It can indicate even the individual cells voltages, and also protects your cell. It has over discharge, temperature protection. It can charge up to 25 maximum amps and a discharge of around 100 amps. And here it has even the thermostat for temperature regulation. So for longevity, if you want these cells to serve you for some good time, for a long time, you need to have a BMS that will be checking your cells regularly and see their balance and they don't go out of balance, because once they go out of balance, then you might lose these cells. So I'm using it. So the fifth part of this build is the inverter. This inverter is a small one. It's rated 600 watts and a surge capacity of 800 watts. It has a blow fan for cooling the inverter or cooling the MOSFETs there, and also this inverter speed increases with the increasing load. So basically on this small inverter you can put on your bulbs, you can charge your phones, you can use your laptop, and I've also tested it to run my small fridge. Since it's a pure sine wave inverter, with a wave which is almost equivalent to that one of the grid, so it can run your fridge properly. So on this build I incorporated the voltage monitor for the DC voltage monitor of the battery, and there you can see it is showing that the voltage on the batteries is 12.2. Down here we have the circuit breaker. One is for the charger, another one is for the battery. So they are basically for putting on and off, and also for protection in case there is a short circuit within the system. These breakers are able to trip and protect and maybe avoid fires, which is very important. So your system should have some level of protection against fires or any short circuit that may be. You never know, anything can happen. So circuit breakers are important and should be incorporated in such systems for safety. So in this build I've incorporated a protection relay. That protection relay is basically for under and over voltage protection within your installation, and also has an overcurrent limiting function, whereby let's say there is a short circuit within your system, it will trip. That means preventing more flow of power into the installation, hence protecting you and avoiding you from fires, because you know short circuits normally lead to fires. And secondly, it will protect your gadgets from being burnt, just in case like the grid voltage increases, it will cut off the supply, hence protecting your installation against damage, your equipment against damage. So I would encourage you, if you have an installation, if you're using power, you should have something that is able to protect you from either, especially over voltage, because it's the one which does a lot of damage. And there are some equipments which are also very sensitive to low voltages, because they're always fluctuating and the gadget needs steady power, and you might find the gadget will also get spoiled because of low voltages. So that relay is basically for over voltage, under voltage, and with the overcurrent limiting function. So mine is rated 63 amps, and it does the job of protecting my installation against such problems. In this build I've incorporated an ATX. This is an automatic transfer switch, because here we have two sources of supply, the grid and my simple power wall. So in order to transfer power between these 2 points of feeds, you need something like that will do the transfer for you. So that's where this automatic transfer switch comes in. It has two modes of operation, the auto and the manual, but I prefer setting it in auto in such a way that if the grid goes, it automatically closes to the side of the power wall, and when the grid comes back, it no longer goes to a part of the grid. Like that. It is very simple. I've been using this power wall with this ATX included for around a whole year, and I haven't had any problems with it. It is working properly. This one is rated 63 for our domestic uses, because most of the maximum current normally for our domestic here, most of the breakers and the switches were normally rated 63 amps. So that is the ATX, which should be incorporated in such systems, not only for the power wall, and even if you're using a generator, she does the job. So we are going to test to see how the automatic transfer switch works, or the ATX, by interrupting the grid briefly. So the grid has been interrupted briefly, and you can see it has operated towards side A, which is being fed by the power wall. As you can see, it was a brief interruption, so the grid has come back, by the other relay still sensing the voltages as if they are normal. It will close and also energize the ATX, and you see the ATX will close towards the grid. So the ATX has operated towards the grid side. So that's how it does its work. If the grid is on, it is on side B. If the grid is off and the power wall is closed, it will flip towards the side of the power wall, making the operation very easy and very safe. In this installation, when you use the ATX, you eliminate a lot of breakers, because if you don't have such a system, you have to put a breaker that you close one side, you open one side. But this unit does it automatically. So YouTube, that is my simple power wall. That's how I built it from this simple box, with some parts that I bought from AliExpress and others that I sourced out from all the electronic parts. Now I'm going to upgrade my system to solar using this inverter that I bought from Circle King. That is on Alibaba. The manufacturer was willing to send me this inverter in a period of less than a month in this COVID time, where shipping and logistics are very hard and complicated. But I was able to receive this inverter from this Circle King. I'm going to be testing it. I'm going to be installing some solar panels and incorporate it into my system, and I see how it works. So YouTube, if you enjoyed the video, don't forget to subscribe and to like for more videos like this. Bye bye.